So we're going to talk today about something called inverse functions. Again, these are brand new. You haven't seen these ones before. We're going to start with the notation, which looks like this. How do we pronounce that? Inverse. Okay, so we don't call that f negative 1x. We don't call it f to the negative 1. We just call it inverse. Okay, and just note the negative 1 is not an exponent. It's just notation. Whoever invented this decided that's the way they want to notate it. So we don't pronounce it any other way than just inverse. What an inverse is, it's a reflection over the diagonal line y equal to x. What the heck does that mean? Well, y equal to x is just a linear function. So let's go back in our head to grade 10. Y equals mx plus b. Tell me how to graph a line. Okay, start at the origin, y, because the b value is 0. And then the slope, so the coefficient in front of the x is 1. So we're going to count up 1 and over 1, and up 1 and over 1, and up 1 and over 1. And then I'm purposely going to draw this as a dashed line, not a solid line, because it's actually imaginary. You don't have to. I just do it in red because it's not actually part of the graph. I don't know. I don't know why I do it in red. I don't know. I like it. Yeah. So the reason we call it imaginary, we call it dashes, because it's not actually part of the graph. It's just the line we're going to flip something over. So it's not actually a linear function on our graph. It's just a line like the y-axis or the x-axis. So we have done horizontal reflections. We have done vertical reflections. What we're adding now are diagonal reflections. So let's start with base parabola y equal to x squared. Tell me how to draw it if I'd never seen a parabola in my life. 0, okay?
Start by going up 1 over 1 on each side, making a point.
Okay.
And up 3 over 1 from there.
Okay.
And then up 5 over 1 from there on both sides.
Why?
Because that's how parabolas are.
A little more about the y? That's the width, yes. And it just comes from the table of values. If the x's go up by 1, the other numbers go up by the squareds. So we're not flipping up and down. We're not flipping side to side. What we're doing is a diagonal flip over this line. That's why it's an imaginary line, because it's not actually part of the graph. So I want you to put a point on the origin. And from that point, I want you to count up 1 over 1. But then I want you to count down 1 over 1. Okay, so over 1, up 1, over 1, down 1. From those points, so I'm at the top one, I'm going to go up 1 and over 3. And from the bottom point, I'm going to go down 1 and over 3. From those new points, how do you think I'm going to count? Up 1 and over 5. And on the bottom point, I'm going to go down 1 and over 5. And there is the inverse to our base parabola. So it's not an up and down, it's not a side to side, it's a diagonal reflection. So remember last year when I said about the direction of parabolas, they go up or down, and that's it. That's the only choice, up or down, up or down. Then I'm like, till next year when we lie to you, because they can go side to side. It's when you're doing an inverse of a parabola, they end up going either left or right. Sometimes what's helpful for these for visual people is I want you to put your ruler right onto that imaginary reflection line. If you don't have a ruler, go grab one. Did anyone actually have a ruler? Because I'd be really excited if they did. No. Don't bend, don't break. Okay, so I want you to put your ruler right on that reflection line. I want you to hold the ruler tight because I don't want it to move. Okay, so I'm pressing down pretty hard because I don't want that to move. And I'm going to take my paper and I'm going to fold it right on that line. Oh my God, did you just fold your notes? Yes, I did.
I don't want to do
No, do it. Do it. Do it. I know, such a badass. Look at that. Sometimes this helps for visual people because if you peek, you can see that they're now on top of each other. So you can see when we fold on that line, the reflection went right back to the original graph. So sometimes that's a good way for people to check if they have the right reflection. See, you people who didn't fold, you don't see that. So if you fold it and you peek, the reflection should be right on top of the original graph. They should be right on top of each other. On your exam, fold it to check it because it's going to tell you right away whether you have the correct inverse or not. You see that? See, right on top? Fold on the exam. Go for it. No one's going to know it was you. Okay, so how do we sketch these graphs? Well, what we actually did is we swapped the x and y coordinates. So if we go back and we look at the origin 0, 0, and I switch those around, it's not going to change. That's why it's still on the origin. Then we had a point negative 1, 1. If I flip those, we get 1, negative 1, which is this point down here. And then I had negative 2, 4, I think we were at. And if I flip those, we have 4, negative 2. And we had negative 3, 9, and we flip those, we get 9, negative. Okay, so that's all we're doing is we are exchanging, switching, flipping. So switch the coordinates. These are fun ones because they look incredibly hard when you see that diagonal line. You're like, what's going on? Seriously, you just flip the coordinates. That's it. XY goes to YX. Okay, let's do some actual examples. So, bunch of graphs. We're going to get the inverse. Then we're going to do domain and range. Kelsey, you're on top of that. Okay. So this is just a parabola like we did from last year. So we know now these are transformations. What is this negative? Vertical reflection. That's why it goes down. What's the 2 inside the brackets? Horizontal translation, 2 to the right. And what's the 5? 5 up. So that's why the vertex changed. It's why the width changed. It's why the direction changed. We're just going to graph this all at once like we did last year. What are the 3 pieces of information we need to graph a parabola? Vertex, width, direction. Vertex, offer of 2, 5. Okay, width, 1, 3, 5, dot, dot, dot. Direction, down. Bless you. Okay, so 2, 5, over 1, down 1, over 1, down 1, over 1, down 3, over 1, down 3, over 1, down 5, bless you again, over 1, down 5. Okay, I'll do the point people the first time. If you're not a point person, just hang out and wait. I'm going to grab, I don't know, this point here, which the current coordinates are 0, 1. Then if we go up, we have 1, 4, 2, 5, coming back around, 3, 4, and 4, 1. Oh, thank you. Inverse, we just physically swap them around, so 0, 1 becomes 1, 4 becomes 2, 5. April's rocking this. 3, 4. And 4, 1. Okay, so point people, go ahead and point those or plot those. Coming back over to the graph for the non-point people, grab the points, physically flip them. So 0, 1 is going to become 1, 0. 1 and 4 is going to become 4 and 1. 2 and 5 is 5 and 2. 3, 4 is 4, 3. And the last one, 4, 1, is going to be 1, 4. Join them in our parabolic shape and make sure you put arrows. If it helps you visually to draw that imaginary line, draw it, but you don't need to have it. If you just want to check it, so put your ruler through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Fold it. Go ahead, do it. Check. Right on top of each other.
Then state the domain and range.
Yes, I just want to do one thing before, so remind me in about a minute to come back to that. So whenever we're dealing with parabolas, and we're not always going to be dealing with parabolas, but if you're a visual person, you might want to note if the original one goes up, the inverse points to the right. And if the original parabola goes down, the inverse points to the left. So that's where I lied to you, that they're not always going to go up and down. Sometimes they go side to side. Okay, turn and talk. Figure out the domain and range of our new parabola. I should have done it in red. Nobody stopped me. Ah. Now it's like a Christmas parabola. Mm-hmm. Yeah, and the vertex will go back onto the original vertex. Since nobody's talking, I'll assume you have these done. Domain. Thoughts, confirmation? Anyone have a different notation? Okay, range? Confirm? Okay, let's do a square root. So first we've got to actually draw the square root, then we got to figure out what's going on with the transformations, and at the final one we're going to do the inverse. Base graph. Take away the numbers. What's the base graph? I heard 0, 0. Awesome. Some of you already have this memorized, which is great. Okay, let's identify the transformations. So the 3 that's inside imaginary brackets or under the root is a, so it's an HT. Agree? Okay, what's the negative 6? Okay, so let's move this sucker. Not red yet because our inverse will be our final. All we're doing is counting. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Go back and check. Bless you. Did you drop this and move it over to the left? Did you physically pick it up and move it? Some people do the inverse. It helps to do that full trick first to see what it's going to look like. So I'm putting my ruler through the middle of the first and third quadrant. So 0, 0, 1, 1, 2, 2. Grab the paper, fold it. Okay, and now you want to look roughly where's that going to go. So right now it's in quadrant 3 and 4. When you fold it, if you were to press on it, where would it be? Something in quadrant 2. Okay, so it kind of already gives us a hint. Roughly we know we're going to be in quadrant 2 somewhere. Okay, how do we do the inverse? Just flip them. So we'll go one by one. The first point on the left. What are the new coordinates? The new coordinates? -6, -3. Okay, the next coordinates? And flip them. Flip them. And the third point is 1, -4. And the last point was 6, -3. Did we end up mostly in quadrant 2? Yep, we did. And again, you can flip. See, are they pressed onto each other? Do they become the exact same graph when you flip them? Write down the domain and range of the red graph. So if the arrow is on the pointing towards the right, the arrow is going to point up.
So where does the x end then?
If it ended here at -3, -6, it's going to end at -6, -3. So they match. Domain, thoughts? Okay, there's the offer. Okay, range. I'm just taking the little mumbles that I'm hearing. Confirm? With the other one what? Okay, so what's the other notation that would match this?
Inclusive bracket, -3 to infinity, circle bracket.
Which we call parenthesis. Example 2, sometimes they'll just ask you to find the equation, so don't graph it. We just want to know is what is the equation of the inverse. So method box for the wordy people. Step number 1, replace f of x for y. Because we learned in grade 10 they're the exact same thing. Step number 2, switch x and y. Step number 3, isolate y. And step number 4, replace y for the inverse notation. Okay, which is that f minus 1x that we just call inverse. It doesn't have a special name. I guess inverse is its special name. So all we're doing here is algebraically what we just did graphically. We're physically flipping the x and y's. We're just doing it with algebra instead of drawing a graph. Okay, so step number 1, f of x comes out, y goes in. Step 2, we're going to physically pick up x and y and change their place. Nothing else is going to move. So x comes to the left, y goes to the right. Didn't change any of the numbers, just physically swapped x and y. I need to isolate this y, so how do I get rid of a minus 1? How? How do I get rid of a coefficient of 2? And with lines, we tend to divide the terms separately on the other side. And I'm just going to flip the order so that the y is on the left. So we get x divided by 2 plus a half. Now mathematically, I can't leave it here because here I have y defined as 2 different functions. Here I've said y is 2x minus 1, but here I'm saying it's something completely different. That's why we need to throw in the inverse notation, because it's actually the inverse that is equal to x over 2 plus a half. So it's just a little math thing we need to switch at the end because we can't have 2 different things defined as y. There's the equation of the inverse. Okay, it's exactly what we did graphically. We just did it this time with algebra. We flipped the coordinates. These are typically 2-mark questions on the exam. So 2 marks, usually 1 for actually flipping the coordinates, 1 getting down to the isolation of f negative 1x. Here's another typical exam question. They'll give you 2 equations and say, are they inverses? So determine if they are algebraically and then verify your answer graphically. So they want you to do it both ways. Sometimes they will be inverses, sometimes they won't be. So determine doesn't mean they are and you are supposed to prove it. It's not like an identity. It means maybe they are, maybe they're not. You tell us. Okay, how are we going to check if these are inverses of each other? Okay, how can they be? Well, let's prove it. So how do we prove algebraically if these are inverses of each other? We just did it last question. Okay, so do you want to work with the first equation and turn it into the second, or do you want to work with the second and try to turn it into the first? You want to turn it into a square root? Don't. Okay, so let's go to the second equation. If we can somehow make it look like the first by flipping the coordinates and isolating, then we know that they're inverses of each other. So step number 1, change f of x to y. Done. Step number 2, flip x and y. Don't change anything else. We're just going to physically pick up x and y and change their spots. How do I get rid of a plus 2? Okay, how do I get rid of a square root? Now, I could FOIL out this left-hand side, but we probably don't want to. Why not? Because we look at this side, right, and it's not FOILed, so we're just going to leave it as x minus 2 squared. How do I get rid of a minus 1? Add it, and then I'm just going to flip the sides at the same time. Are they inverses of each other? How do we know? Because they're exactly the same. So yes, these are inverses. So Noah, how does that work if one's a parabola and one's a square root? Well, let's do it graphically, and then we'll see what happens. Okay, so graphically all we're going to do is graph both of them, and then we just want to show that they're the diagonal reflection of each other. So let's start with the parabola. What are the 3 pieces of information we need to draw a parabola? Vertex, direction, width. Okay, what's the vertex of this guy? 2, 1. I made this graph really huge for some reason in the notes. Yeah, it's like really big. Does it go up or does it go down? Up, and what's the width? Okay, so over 1, up 1, over 1, up 1, over 1, up 3, over 1, up 3, over 1, up 5, all the way at the top. But wait, there's crap here that we didn't talk about. You can't just ignore stuff that comes after a function. There's a reason mathematically why it's there. That is a domain restriction. So it's telling you, just like on the unit circle, where your graph can be and where your graph can't be. What does this mean mathematically? So what is this telling you in words? The x has to be less than or equal to 2. So what does that mean in terms of our graph? Half of it is gone. So which is gone, the left-hand side of it or the right-hand side of it? Where are the numbers that are not less than 2? So this whole side of the graph is gone. Okay, simply because of the domain restriction given in the question. Now earlier, the reason Noah was asking is because if we have a full parabola and we flip it, we've already seen, is we end up with the parabola on its side. But the square root graph only has half of that. So without the domain restriction, these would not be inverses of each other. It's because of this now, when we flip it, we're just going to get a square root graph. Okay, how do we draw the inverse, or how do we draw the square root graph? So go back to this that you can't see. What's the base graph? What's the base graph for this? Take away the numbers. What's the base graph? Square root. So let's just quickly draw a square root graph. And I'm doing it really lightly because we're going to move it right away anyway. What's the -1 and what's the 2? Okay, vertical and horizontal translation, 1 to the right and 2 up. So let's move all these points. 1 to the right, 2 up. And I'm going to get rid of my base graph because I don't want to mix it up with what I know about the inverse. You don't have to erase it. I just don't like it to be there. Have we graphically shown these are inverses? How do we know? No, so we can do the paper and we can fold, or we can look at the coordinates. So did 2, 1, did it flip? Did it go to 1, 2? Yes. Did our point here 0, 5? Did it flip and go to 5, 0? Okay, now what? Well, but we proved here it was, which either means we made a mistake up here or we made a mistake down here. So figure it out.
We made a mistake up top because we didn't put the range or the domain into, we didn't think about that.
Not necessarily. We accounted for that here. Okay, so we have conflicting results.
The other side of the parabola is the inverse.
Explain.
Well, like I still have the points there, and all of the points are the opposite.
Okay, so when we flip this, what side of the parabola did this flip?
The right side.
It flipped the right side. But the domain has restricted us to the left side. So are these inverses of each other? No. So where is our mistake in this? It's up here. It's the conclusion up here. If this has to be less than 2, pick a number that's less than 2. 1. If I put 1 into here, into this one, where am I? Or into this one, which you can't see. Note that now I'm totally mixed up, into this one. Right, it's not going to work because of here. So again, when you look at this, you can't just say, oh yeah, no, they're inverses of each other. You need to do some kind of check. You either fold, and if you fold, you would have seen they didn't lie on top of each other, or you're physically checking the points. So let's just go through that again. We said that 2, 1 should become 1, 2. We're good with that one, okay? We had 0, 5 should have become 50. So what is the conclusion to all this? No, not inverses. And this becomes really tricky with the parabolas and the square roots.
Where did you guys get the 3, 2 from? 2, 3 from?
The 2, 3, this point here.
Yeah.
Okay, where did it come from?
Came from the other side of the parabola.
Don't know, so you guys.
Because if we were restricted to the domain x can't be greater than 2, shouldn't we have used all the points from that side?
But we were graphing this, because we were not taking this and drawing the inverse, because that's not going to prove their inverses. We were drawing this. So yes, absolutely, what this ends up being is the other side of the parabola, but we don't have it.
Okay.
Questions? This will come into play with square roots and parabolas, because the problem with parabola is it has the two sides, the square root only has the one side. So it's not enough to just do it algebraically, sometimes you need to do it graphically to prove. I see some blank faces there. No questions? Nobody's saying anything?
If we just solve the algebraically, it would be inverse.
Well, sometimes you can't tell, right? Because you look at this, you're like, looks good, but sometimes when you draw it, not so much. No, no. You would do it graphically with parabolas and square roots.
You can do it algebraically, though. I just did it.
Yes, but if you're not sure, do it graphically and look at it.
So on the exam, it would have us be both.
Sometimes yes, sometimes no. Sometimes they'll just say, determine if it's an inverse. They won't give you a method. So I'm saying if you're going to do algebraically, great, but sometimes you want to double check it graphically, because sometimes it's a little more obvious with the graph. That's all I got for you today. 243.